Students, let's start our today video related to electric dipole. Now first of all, let's start with electric dipole. Dipole. Di means two, pole sides or polarity. So electric means charge. So if two charges of opposite polarity are separated from each other by a given distance t, then they constitute a electric dipole. So electric dipole consists of what? Positive charge, negative charge, q, q. This is also q, this is also q. But one is positive, other is negative. Their polarity is different. One is positive, other is negative, but their magnitude of charge is same. If this is 2.5 microcoulomb, this is also 2.5 microcoulomb, and they are separated from their center by a distance d or a distance 2a. In some books it's taken as d, some as 2a, or in some as 2d. This, so there is no so much difference. So it's depend upon you what you are going to take, and in further expression you have to go for that. Now, if distance between them is d or 2a, then it's constitute a electric dipole. So electric dipole consists of a positive charge, a negative charge separated by a distance d between them, or distance 2d between them. So this is called electric dipole. So this constitute electric dipole. So electric dipole consists of what? It consists of two charges of opposite polarity but same magnitude separated by a distance d or 2a between them. So electric dipole consists of two equal and opposite charges separated by a distance d. Now next is electric dipole moment. What is electric dipole moment? Electric dipole moment. What it is? Electric dipole moment is represented by p vector. It's a vector quantity. Like E is directed from positive to negative. Electric dipole moment is directed from negative to positive. So the direction of electric dipole moment is from negative to positive. It's a vector quantity having direction from negative to positive represented by p vector. Apart from it, electric dipole moment is equals to product of either charge into distance between them. If we say electric dipole, that is positive, negative, charge on both of them is q, distance between them is 2a. In that case, electric dipole moment equals to product of either charge, either this or this, but only we have dictive magnitude, into distance between them. This is electric dipole moment. So P is what here? Electric dipole moment is Q into 2a or 2qa. Yeah, if we take it d, it's P equals to Q. So this is going to be. So now next is what we have to find. So here this is the electric dipole but with a distance of 2a between them. Next we have to find electric field due to electric dipole on its axial and equatorial point. Now what is axial and what is equatorial plane? We have to find this first. If this is a dipole, positive, negative, this is the center of this dipole, say O. This is charge Q plus Q, this is minus Q, this is point A, this is point B. Or if we say negative, positive, this point is the center of dipole O, minus Q plus Q, A, B, distance between them, say D or 2A, whatever you are going to take it, A. Now there are 2 points. If we take along this axis, the line which is passing through the center, like this is axial line. This is which line? Axial line. And this is center, a plane passing through the center but perpendicular. A plane passing perpendicular or line passing through passing through the center perpendicular. This is called equatorial plane or line. So this is equatorial. This is axial. Now what we have to do? We have to find electric field due to a point on the axial line and equatorial line. So we are going to find the expression of it further. So now let's first start with electric field on axial line of electric dipole. So this is electric dipole here. This Q, positive Q, negative Q. This complete is axial line. Now what we are going to do? If this is a complete axial line, this is point P. We consider this point P where we have to find what electric field we have to find. This is plus Q, this is minus Q, this is distance between them, this is the point taken on the axial line. So it is appear to be like negative charge, positive charge, separated by a distance 2a between them, axial line. This is point P where you have to find a electric field due to charge Q plus Q and due to charge minus Q. Let this is be point O and distance between point P and center is R, say. If this is center point, then this distance is A. This distance is also A. So if we take here A point, negative, positive, P point, O, P point. So AP equals to this distance is R, this distance is A. So it's R plus A. Now if I have to find BP, this complete is R and this is A. So this is R minus E. So we can say AP is equals to R plus A and BP equals to R minus A over here. Now what you have to do in this, you have to follow two steps. Like first you have to find the electric field due to both positive and negative charge. Second, you have to find out the component if components are there. Second step is valid if components are there. If no components are there, you have directly move or jump to the step 3, that is you apply superposition principle to find the net electric field at a given point. So first point is to find E positive, E negative. Second point, to find the component if exist. This is conditional. And third point, apply superposition principle to find the net electric field. And after that, when we find the net electric field, we will find a electric field on dipole, which is short electric dipole. That's just a one-step process. We'll do it later. Now next is first, like we are going to first find field due to positive and the negative charge. So this is E negative, means field due to this negative charge. Due to this negative charge field, as we know, formula of field due to a point charge, that is 1 by 4 pi epsilon naught charge upon distance. This is the formula. This is the formula of what? This is the formula of electric field due to a point charge. If we want to express it in a vector form, as we know, this is now at point P we take unit positive test charge. If P is unit positive test charge plus Q naught, it is, now this is negative charge, this is positive charge. So field is going to be what? This negative charge is going to attract this positive charge. So this is direction of EQ. minus EQ, or I can say it's just a point A. So EA, if we consider this point A, this point B, so this is direction of EA. In this direction, EA is acting. Now dipole moment is from negative to positive. Dipole moment is this direction. So EA and EP both are opposite to each other. So we can write EA equals to, what is the formula? 1 by 4 pi epsilon naught charge, that is Q, upon distance. Distance between this and this, that we already know, A and P, that is R plus A whole square. Now take to the direction. As P is in this direction, EA is in this direction. As we have to take only direction, so we take P cap. So P cap will take here, but negative sign show here. These both are in opposite direction. EA and P both are in negative direction. Now next we will find field due to point B or positive charge. So due to point due to positive charge or at point B, the field is going to be Q 4 pi epsilon naught, as this is due to EB equals to. Now positive P point also have unit positive charge. So it's going to repel it in this direction. This is EB. As P was already in this direction, so this both are in same direction. So we'll take here, what will take? Positive sign. EB equals to 1 by 4 pi epsilon naught Q by, now distance between them was R minus A whole square. Now no negative sign is required over here, and we take just P cap. No negative sign required. This is not required over here. Now next we have to do, as here there is no component is required, so we directly jump to the step 3, that is we apply superposition principle. Superposition principle state that net electric field at a point is equals to the sum total of vector sum of the other electric field, that is vector sum of EA plus EP. Now what was EA? EA is equals to, sorry, I'm just going to substitute the value. Net E total is equals to, EA is 1 by 4 pi epsilon naught with the negative sign Q by R plus A whole square P cap plus 1 by 4 pi epsilon naught Q R minus A whole square into P cap. This 1 by 4 pi epsilon naught Q R plus, P cap, this all going to be common, as this both are common, but R plus A whole square, this is R minus A square, and this is with negative sign, this is with positive sign. So we are going to taking things common which are actually common. So E total equals to 1 by 4 pi epsilon naught common, Q common, inside we left with minus of 1 by R plus A whole square plus 1 by R minus A whole square into P cap. If we going to solve this, then by solving this step you will directly move to that Q by 4 pi epsilon naught 4AR upon R square minus A square whole square P cap. This is the step after solving, that's just a mathematical step it is. So we get what, or I can solve it for you. This is 1 by R plus A whole square with minus sign plus 1 by R plus A whole square. We are going to solve this. This is minus. Now A plus B, A minus B. When we take the LCM, we get R minus A whole square, R plus A whole square. So minus of R minus A whole square plus R plus A whole square. So when we open this A minus B whole square, A plus B whole square, and this is what? A minus B, A plus B with a square. So we get here, I'm going to open the bracket, minus R square, A square minus 2AR plus R square, A square, 2AR upon R square minus A square. A square, A plus B, A minus B, and whole square. This is, if we open this minus sign or we open this bracket, this is going to be negative, this is going to be negative, but this is going to be positive. So further we are going to get what? We are going to get minus R square minus A square plus 2AR plus r square plus a square plus 2ar upon r square minus a square whole square. This r square, a square cancel. We get 2 plus 2, that is 4ar upon r square minus a square whole square into p cap q by 4 pi. So this is the final result. So final result is what? E net is equals to 1 by 4 pi epsilon naught 4ar upon r square minus a square whole square into p cap. Now I'm doing to do one more thing. I can write this 4ar as 2a into 2r. Here's q also. Yes. I can write this. Now q into 2a is what? This is dipole moment p. This is p over here. So we can write E vector as 2r upon 4 pi epsilon naught r square minus a square whole square into p cap. This is p vector. This is what? P vector. So in vector form we can also write E vector equals to 1 by 4 pi epsilon naught 2 p cross r upon r square minus a square whole square. Now if we consider the case of short dipole, which dipole? Short dipole. For the short dipole, r is very greater than a. R is very greater than a. So in that case, this r square minus a square, this led to only r square, because r is very less greater than a, and r square minus a square, this is going to be very greater, so this is neglected, so we get r square. So in general, if I write, this is E vector 1 by 4 pi epsilon. If I write it in same form, 2r p vector upon r square whole square. 1r get cancelled with this r. So we get what? We get E vector 1 by 4 pi epsilon naught. That is 2p vector upon r cube. This is the result of electric field on axial point due to short electric dipole. So this is the case with electric dipole, electric field due to electric dipole on the axial point. Now we are going to discuss about equatorial in the next. So this is the result. You can see E is equals to 2p 4 pi epsilon naught r cube. This is for the short dipole. Now let next move to the electric field at equatorial point of electric dipole. Now we are going to take equatorial line. So if it's again positive, negative, distance between them say 2d or 2a or 2d or 2 d or 2a, it's taken over here d, or you can also take it as 2a, but you have to proceed according to that. So let's say I am taking here 2a instead of t. I'm taking here 2a. I will also tell what you have to change over here. So now you have to find, or we have to find, what? Electric field at equatorial point. First of all, we consider equatorial point on equatorial plane. So let's do that. So this is positive, positive, negative, q minus q, center point, line passing through the center, that is equatorial. So this is the point where we have to find electric field. Now first step is to what? At point P we'll consider unit positive charge, that is plus q naught, because we have to find the field. Now dipole moment is from negative to positive. This is the direction of dipole moment P. We have to find, first step, electric field due to this negative charge at point A and positive charge at point B. First step is to find electric field. So to find, if we taking this as 2A, I'm going to make it more clear. This is negative, this is positive, this is A, This is P, this is charge minus Q, this is charge plus Q, center O. This complete is 2A. So if this complete is 2A, then this is A, this is also A. In the expression given below, they has taken only D, then this is D by 2, this is D by 2. But I am taking here 2A, so this is A, this is A. This is a point P on equatorial line where we have considered an imaginary unit positive test charge. So first we find this distance and this distance, only then we can find electric field over here, magnitude of electric field. Now this distance is what? If we consider this distance between O and PBR, O and PBR, this is a right angle triangle, this is a right angle triangle. We know the base is A, this is R, then this is what? Under root of R square plus A square. Similarly, this is A, this is R, this is under root of R square plus A square. Now we get the distances. So we have what? We have AP. AP is equals to under root of R square plus A square. BP is equals to under root of R square plus A square. Now electric field due to point A, that is negative charge, it's going to be 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught charge, that is Q, upon distance square, that is R square plus A square. Similarly, B is going to be same, 1 by 4 pi epsilon naught charge, that is Q again, distance square, that is R square plus A square, because it was roots and square was there, so it's get cancelled. So this both has same magnitude. EA and EB has same magnitude. Now let's see about what about their direction. So let's consider their direction. So again, negative charge, positive charge. Point P, point A, point P. Now this is unit positive charge Q naught. Negative charge is going to attract this positive charge. So direction of EA is in this direction. This is direction of EA, because negative is going to attract this positive toward it. This positive, this positive. So this positive is going to repel it along the center. So this is direction of EB over here. Direction of EB. Now this is direction of EA. This is direction of EB. Now we require the component. If I draw this as x-axis, this as y-axis, then we have component of both. Now what's the component? If I consider this angle, let this angle be theta, this is also theta. Why so? Alternate interior angle. This is theta, alternate interior angle. Now again, if this is theta, as this both sides are equal, so if two opposite sides are equal, opposite angle are also, if this angle is also theta, if this is theta, this is also theta, corresponding angle. So this is theta, this is theta. Now we are going to resolve their component. We are going to move on second step. Here second step is valid because component exists over here for them. So this is EA, this is EB, this is x-axis, this is angle theta, this is again angle theta. If we remember, then the vector making an angle theta with the axis, then we have a component of cos theta, that is this is EA cos theta and this is EB cos theta. But along the perpendicular we have what? This is EB sin theta, this is EA sin theta. Now EB sin theta, EA sin theta, as EA and EB equal in magnitude, sin theta value is also going to be same, but they are opposite direction. EB sin theta is in upward direction, EA sin theta is in downward direction. So they are going to cancel each other. So we are going to left with only this component. This is in this direction. This is EA cos theta and EB cos theta. EA cos theta and EB cos theta both are in same direction. Which direction? In this direction, so they are going to be add up. This sine theta is going to be get cancelled, but EB cos theta is going to be add up. So we get what here? We get the component, and so net is what? E net is EA cos theta plus EV cos theta, because sine component has cancelled out each other. So EA and EV equal in magnitude. Can we write it as E, as their magnitude is what? That is 1 by 4 pi epsilon q by r square plus a square. So we can write it E net is equals to E cos theta plus E cos theta. So this is what? 2E cos theta. So E net equals to 2E cos theta. To find value, we have to substitute the value of E. That is what? 1 by 4 pi epsilon naught. Sorry for that. That is, really sorry for this. That is E is equals to 1 by 4 pi epsilon naught. Again, Q by R square plus A square. So E net is equals to what? 2. Instead of E, we can substitute this value into cos of theta. Means we also require the value of cos theta now. Now, in this triangle, if we came back to this triangle, A, B, P, this angle is theta, this is A, this is R square plus A square under the root. This is A. This is theta. This is 90 degree. So if we find cos theta, this is base, this is perpendicular, this is hypotenuse. Cos theta is what? Base by hypotenuse. So base is A, hypotenuse R square plus A square. So we are going to substitute the value. So cos theta is what? Cos theta is base, that is A, upon hypotenuse, that is A R square plus A square whole the root. Now I'm going to substitute value. E net is equals to 2 times 1 by 4 pi epsilon naught q upon r square plus a square into cos theta, and this is the value of cos theta. So E net is equals to 2 times 1 by 4 pi epsilon naught q upon r square plus a square into a upon under root of r square plus a square. So we get this. So this is 2qa, and you know 2qa is equals to what? P. 2qa is equals to P, and upon r square plus a square into r square plus a square under the root. Base are same, power is 1, power is 1 by 2 over here. So power is going to be added. I'm going to do more clearly. That is E net is equals to 1 by 4 pi epsilon naught. We get here 2qa upon r square plus a square power 1 into r square plus a square power 1 by 2. Base same, power going to be add, that 1 plus 1 by 2, that is 3 by 2. So E net equals to 1 by 4 pi epsilon naught. This is what? P upon r square plus a square raised to power 3 by 2. Now let's see the direction of it. This is the magnitude of net electric field. Now see the direction of it according to the P, because we have P here. So what we observe, if this is a dipole plus negative, so dipole moment direction is this P vector. This is point P, and net electric field is observing in this direction, E net, because both cos theta are in this direction. So this P and E both are in opposite direction. So if we want to write it in vector form, we write E net vector form. E net vector form is equals to 1 by 4 pi epsilon naught P vector with minus sign because both are opposite upon r square plus a square raised to power 3 by 2. So we get what? We get E net vector is equals to minus P vector 4 pi epsilon naught r square plus a square raised to power 3 by 2. If we find it for short dipole again for short, r is very greater than a, then r square plus a square, it's almost to be equals to r square over here. So here we get r square. So we get E net is equals to minus of P vector upon 4 pi epsilon naught r square whole raised to power 3 by 2. 2 get cancelled with this 2. So we get E net is equals to minus 1 by 4 pi epsilon naught P vector upon r cube. This is the result for equatorial. And if we remind for the axial, it was 1 by 4 pi epsilon naught 2p vector upon r cube. So if we take ratio of E axial to E equatorial, all is going to be cancelled. If we take this ratio of magnitude, not direction, only magnitude, this whole going to divide, we get 2 ratio 1. So E axial ratio E equatorial, that is going to be 2 ratio. So electric field due to the axial is more than as compared to electric field due to equatorial. So we can see here whatever we have done. This is the result. This is with d by 4. So instead of d by 4 we get here a square. A square. This is 2d. 2a sorry. Again a square. A square. A square. A square. Everywhere we have taken only a square. Now this is the step for short electric dipole. As E electric field and dipole moment both are opposite to each other, so it's used here word anti-parallel. Now there are some points. First point, intensity due to dipole varies as 1 by r cube. We have observed in both cases axial and equatorial, this E varies inversely proportional to 1 by r cube, and this approaches to 0 unless this approaches to infinity and P approaches to 0. Second point is E will be maximum when cos square theta is maximum and minimum when cos square theta is minimum. That's obvious because it depends upon cos theta. And last again, so the electric field at axial point is parallel. So for the axial electric field and dipole moment are parallel to each other. But for equatorial, they are anti-parallel to each other. And if we take the ratio of the axial to equatorial, that is 2 ratio 1 over here. So this is the electric field due to electric dipole on equatorial point. Now let's move to the next topic, that is torque and amount of work done if an electric dipole is placed in a uniform electric field. So let me clear you about first what is torque. As in plus 1 we already learned torque is what? It is a rotational force. Rotational force means which actually create a rotational effect on a body. Torque, it is represented by tau. Its formula is force, either force into perpendicular distance between forces. I will clear you what this formula actually stands for. Either force into perpendicular distance between two forces. This is the formula of torque and this is the symbol of torque, that is tau vector, and it's a vector quantity here. First we are going to find what? We are going to find torque on electric dipole placed in uniform electric field. Uniform, this electric field is uniform, its value is going to be same for each and every point and every area. So the diagram for this is, This is uniform electric field. Now, if I placed an electric dipole over here, negative, positive, and it's making an angle theta with the axis. This is the angle theta with the axis. This is E vector or theta with the field. Now, this is negative charge. Field is always from positive to negative. Dipole moment is from negative to positive. This is direction of dipole moment. Dipole moment is making angle theta with this electric field. P and E making an angle of theta with each other. It's mean P and E both are making an angle of theta with each other. So this is theta, this is also theta. So they are making an angle of theta with each other. Now this is negative charge. This is going to attract toward this force, this side, and this positive charge is going to attract toward this side. And we know force is equals to what? QE, that we learned in previous video, that force is equals to QE. So on this the force Q into E, because E is same for both, charge is also some for this charge force is QE. So these are two forces, this and this. So we are going to take either force, either this or this. This is the force and the perpendicular distance between them. Now say about the perpendicular distance between them. Electric field, negative, positive, plus QE minus QE. I'm just taking the magnitude, so that's why I'm not putting sign over here. This force is acting along this line. This force is acting along this line. This is the perpendicular distance between these two forces. Perpendicular distance between these two forces. I have to calculate this. If this distance is 2a, this distance is 2a, and this angle is theta. So we can find this. Yes, we can find this. This is angle we have to find this perpendicular distance we have to find. So to find this perpendicular distance, we know what this is: 90 degree. This is angle say this is angle theta, and this is hypotenuse. This is hypotenuse, this is angle, this is theta. We have to find this perpendicular distance. So this hypotenuse is 2a over here. So we use formula sine theta is equals to perpendicular by hypotenuse. So perpendicular equals to what? Hypotenuse into sine theta. Hypotenuse is here 2a sine theta. So this perpendicular distance between two forces, perpendicular distance, perpendicular distance between two forces is 2a sine theta, and either force is QE. Either force, either that or that is QE. So we are going to substitute the value. So tau is here, either force, that is QE, into distance between them is 2a sine theta. Now Q into 2a, Q into 2a, this is what? This is 2qa, this is P vector, dipole moment, this is dipole moment, this is E sine theta. So we get here tau P E sine theta. So sine theta stands for cross product, so we can write tau cross equals to, so tau vector equals to P cross E. So this is torque. This is torque acting on the electric dipole placed in uniform electric field. So that is P cross E. P cross E. Now next we have to find what? We have to find amount of work done in rotating a dipole in uniform electric field. So suppose if dipole is placed like this, making an angle theta with the field, if we rotate it by a small angle, then how much amount of work is done? Because if we know in the presence of field, if we do displacement, either it is angular or linear, then amount of work is done. So work done is here what? This is rotational force. Work done in formula is force into displacement, but here instead of linear force there is torque tau, and instead of linear work there is rotational work, that is d theta, then small amount of work dw is done. Suppose if we want to rotate it from angle theta 1 to theta 2 now, then we have to find the total amount of work done. So amount of work done dw is equals to tau d theta. Tau is what? Pe sine theta into d theta. If we find out the complete work done, that is integration, and again here integration tau d theta from theta 1 to theta 2. So it's going to be integration theta 1 theta 2 Pe sine theta d theta. As dipole moment is constant, because charge is not going to not going to change, distance between them is not going to change, electric field is also uniform and constant, so this both factor are uniform and constant, so we take it out of integration, so we get here dw is equals to P e integration sine theta d theta theta 1 to theta 2. Integration of sine theta is what? Cos minus cos theta minus cos theta. So we get W P E minus cos theta theta 1 minus theta 2. I'm taking minus sign, comma, taking outside the bracket. So we get W is equals to minus PE cos theta theta 1 theta 2. So upper limit minus lower limit is the formula. That is upper limit is cos theta 2 minus lower limit is cos theta 1. So W is going to be minus PE cos theta 2 minus cos theta 1. So we get here, if we consider here theta to be 0 and theta 1 to be 90, as cos 90 is what? 0, cos 0 is 1. So we get here W is equals to minus PE, or we can say if we consider theta 2 to be theta and theta 1 to be 90, then we get W is equals to minus PE cos theta 2, instead of theta 2 I'm writing here theta, minus cos 90 is 0, so we get minus PE. W is minus PE cos of theta. This cos theta stand for dot product, so it is minus P dot E. So this is the expression of amount of work done, and whatever amount of work is done, that is stored as a potential energy of the system and is represented by a symbol U. So potential energy is equals to minus P dot E. So potential energy to rotate a electric dipole in uniform electric field, that is dot P dot minus P dot, where dot stand for force. So this is the diagram for electric dipole placed in a uniform electric field. Next, this is force on one, force on other. Translatory force is 0 because they are going to cancel out each other, but they are going to exert force, which is, it's going to be tau is equals to E sine theta. Then we calculate the work done. Work done is equals to, if we consider angle 0 to 180, 180 is what? Minus 1. 0 is 1. So minus 1, minus 1, minus 2, minus minus plus, so 2 PE. Now next there are two stages or 2 points. One is stable equilibrium, second is unstable equilibrium. Stable equilibrium means when the dipole is in stable state and no force is acting on it, no torque is acting on it. That is the case of when angle between them is 0. When tau, as tau is equals to Pe sine theta, if theta is 0, then this factor is going to be 0, this net is equals to 0. If equilibrium condition means, stable equilibrium condition means when tau is 0, net force is 0, as net force is already 0, but tau, when tau becomes 0, then it's stable equilibrium almost. So tau is equals to 0, so it's stable equilibrium when it's when theta is equals to 0. and in that case potential energy is maximum, and because theta is 0. For unstable equilibrium, that is theta is equals to minus 180 degree, and tau is maximum, that is minus, in that case this is an unstable equilibrium, even though the tau is 0, but even though a force is acting on it. Now next, and first in stable equilibrium P and E both are in same direction, you can see here. Unstable equilibrium P and E both are in opposite direction. So when theta is equals to 0, potential energy is minimum tau is 0. So it's having dipole moment parallel. And when theta is equals to 180, potential energy is maximum in that case. So that's why it's unstable. It's trying to attain a stable state. Tau is again 0. So in this case, this is dipole moment is anti-parallel. Not parallel, this is anti-parallel. Anti-parallel to electric. So that's it. This is a complete topic of electric dipole. It's field on axial point, equatorial point, and its behavior in uniform electric field, like what's the torque acting on, what's its potential energy, stable equilibrium, unstable equilibrium. That's it. In the next video, we cover further topic. Okay.